Good morning. Today is Sunday, October the 5th. A member of our class sent me an email, and she said she didn't quite understand voltage dividers. So what I would like to do is discuss voltage dividers a little bit with you and work a problem. First off, why do we need a voltage divider? Let's say that we need a certain voltage. Let's say that we need 5.47 volts on the base of on the collector of a transistor. This is what we want. And let's say that we want 4.53 volts somewhere else in the circuit. Okay, what we've determined already is that these two resistors will give us that voltage. Now though, I'm going to prove that to you, that those voltages will be produced by this combination of 68 ohms and 82 ohms in a 10 volt circuit. Now I've simplified this circuit, and I want you to see that this ground here is not necessary, but what it is, it's showing a visual picture of how the output voltage is going to be taken off. So I'm going to take my output voltage from here to here and from here to here. Part of the circuit, like I suggested to you earlier, needs 5.47 volts, and the other part of the circuit needs 4.53 volts. Now it's important that you understand that a voltage divider is merely something of resistors, or it could be some other components, but in this case we're going to use resistors here in DC circuits. We're going to use resistors, and what it does, it takes the source voltage, in this case 10 volts, and it divides it up, hence the name voltage divider. It divides it up. I could have divided it up to 4 or 5 different voltages, and I could have made this 100 volts, and I could have got different voltages off of this. But that's all I want you to see right for the second, that the purpose of a voltage divider is to tap off certain voltages that you want to use somewhere in your circuit. Now the voltage divider requires a little thought though. There's several formulas that we can use for this, and let's start off by the voltage divider formula. Now let me try to, there we go. Now we start off with the voltage divider formula here, which is Vx. Let me make this a little clearer here. Vx equals Rx divided by RT times the voltage source. In this case, we're running a battery. Now, I really don't like to use this type of diagram anymore. I found out it's a lot simpler to redraw the diagram, and this diagram here is the same as this diagram here. So let's work with this diagram. Okay, notice that we have a 10 volt source, and we have R1, which is 82 ohms, and R2 that's 68 ohms. Now this formula may seem a little difficult to some of you right now, but it's going to be very clear to you soon. And what I'm going to try to demonstrate, that each resistor is part of the total. Now that's not a difficult concept if you will open your mind and allow yourself to think that R1 and R2 comprise the total, RT. But R1 is just a little part of that RT. Now if we think of it clearly, we can rearrange this formula here, and that's what I'm going to do here. I want to know the voltage across R1. So it makes sense that I would use R1 as part of the fraction. And that's what this is. This is a fraction here. Let's give you a little example. Let's say that you had 10 over 1. I'm sorry, 10 over 100. Now 10 over 100 is very familiar to us, because this might be 10 cents. 10 over 100 equals how much? Well, since we're always depending on our calculator, the first thing we need to do is set up our calculator. First thing we do is turn it on. I see that I'm still in scientific notation from another time, so I'm going to turn it off, and I'm going to reset it and go slowly so that some of you who are not real versed in using your calculator yet, you will become versed as time goes on. Now let me hit second, because what I'm doing, I'm putting the calculator into the scientific mode, and these are second functions. Now the science mode, SCI, is underneath the 5, so I hit the 5, and you can see that I've gone into scientific notation. I repeat this over and over. We want to have an accuracy of 2 decimal points. So I hit the second, and I hit the fixed, and I want 2 decimal points, so I hit the 2. Now notice the calculator is now set up to solve the problems that we have to 2 points, or 2 decimal points accuracy. Now let me go on. Let's use this example here of 10 cents and $1. Now the first thing I need to do to divide, of course, is put in the 10, hit the division signal, and 100. Now notice here that I come out with 1.00 and times 10 to the first. That tells me that I need to move my decimal point to the left. Okay, so I come out with equals 0.10, and we know from basic mathematics that that equals 10%. Is that clear? Same thing we could have done here. 50 cents over $1 equals how much? Let's use the calculator. I know it's a simple calculation. I know you can do it in your head, but I want you used to using the calculator. So I push in 50 divided by how much? 100 equals 5.0. Okay, I move my decimal point in this case. Let me do that again. I put in 50 divided by 100, and that equals 5.00 times 10 to the minus 1. That means that I'm going to move my decimal point to the left 1 point, so that it'd be 0.50. Decimal point 0.50, which in this case is 50 cents, and we all know what 50 cents is. 50 cents is 50% of $1. Okay, now that we have established that, let's look again at the formula. Notice here that we have the whole thing. We have the whole total resistance, and I'm going to equate that to the dollar. Remember the dollar? Okay, the dollar was the whole, and I found the total resistance by this formula here, that RT in a series circuit equals R1 plus R2, and in this case that was 150 ohms. So that's where the 150 ohms came from. 150 ohms is RT. Now our first resistor, which is R1, is 82 ohms. So I put the 82 ohms over 150. 82 is a fraction of the whole thing of 150. And in this case, I multiplied it times the voltage, which was 10 volts, and I got 5.47. Let me put that in there so that there's no confusion. This is times 10 volts. Okay, now that I've established that, I've established that 5.47 is the voltage across R1, this 82 ohm resistor. Now there's two ways I could work this. I could say that that V2 is going to equal Vs, which was 10 volts, remember? 10 volts here, part of the whole, minus V1, which in this case was 5.47 volts. So I'm going to write that down. 10 volts minus 5.47 volts equals 4.53 volts. So I could have established our second voltage across R2 by this formula here. But another way I could have done it is the way I actually did the first one. I could say that R2 is part of RT, is a fraction, and it's going to give us a percent. So I could say that V2 is equal to R2 divided by RT times Vs. And again here I've left off the 10. I just did that on the calculator. 10 volts. And that is equal to 4.53 volts. Now if we want to check our work, we can add those two together. 5.47 plus 4.53 equals 10 volts. So now I know that I've done the problem correctly, and that I've worked it two ways. First, I solved it with the voltage divider formula, and then I solved it with what? Kirchhoff's law here, that the sum of the voltage drops around a closed loop is going to be algebraically equal to 0. And then I solved R2 in the same manner as before, using the voltage divider formula. Well, I hope that answered your question, the student that gave me an email about it. If you have any further questions, you know my email address, and I'm always pleased to receive questions. I enjoy doing mathematics involving electronics, and basically all of these formulas are just pure math, and we just have to learn to manipulate those. Many of you already know how, because you had that in algebra, but for those who haven't, that's not a problem either. We'll learn here together. And of course, I strongly recommend again, do a lot of practice using your calculator. Do not do these problems in your head. And the reason for that is the problems now are fairly simple that you could do in your head. But as time moves on, then we're going to use more and more, we're going to depend more and more on the calculator. Now, although this is in series problems, what I've discussed today, the voltage divider, and notice here I delineated it, it's going to be in series circuits. Now later though, we're going to do series parallel, and we'll bring this back into play. So that's not too far away. This month here of October, we're going to be mostly in parallel for a while, and we're going to be doing some labs. And that brings up a point. The students who have not completed Lab 4, we're going to finish that off Tuesday. And I'm going to look forward to seeing your papers turned in on all the homework that you've previously done. And we discussed before, and I'll discuss again, and I hope I don't have to discuss it again. Here's how you can turn in your paperwork. You can send it to me by email. All of you have my email address. Or you can copy it and bring that to class. Or you can tear the pages out of your book and give those to me. You won't see these pages back. So I urge you to pick the method that you enjoy the most. Okay, I'm going to go ahead and close this lecture on voltage dividers, and we'll be coming to other subjects as you write in. I hope that I have a lot of questions this weekend. I have some time. I have someone doing my work for me. When I say my work, my honeydews, all of you have heard of honeydews, you married people especially. There's no rest for people. Well, I won't go into that. That's not the right thing to do. I'm joking. Okay, that's it. Bye.